In this video, I am going to teach you how to find the discriminant of a quadratic equation, and also I will relate that to the nature of the roots of a given quadratic equation. But first, what do you mean by discriminant of quadratic equation? So the discriminant reveals what type of roots the quadratic equation has. So when we say type of roots, we're talking about, is it imaginary? Is it rational? Is it irrational? So those types of, questions, or those types of numbers, or those types of roots. And here, the number d, which is b squared minus 4ac, this is the formula for determining the value of the discriminant. I think you're familiar with b squared minus 4ac. That's the algebraic expression inside the quadratic formula. So given the quadratic equation in standard form, ax squared plus bx plus c, we will use those coefficients just like using quadratic formula in order for us to find the value of the discriminant. Okay, so before I give you and discuss to you 4 examples here, let me just show you the nature of the roots. So I mentioned this earlier. Nature of the roots, we're talking about what kind of numbers or what kind of roots. Is it going to be imaginary, irrational, or rational? Now, some teachers, they only divide the nature of the roots into two, imaginary or real number. But I want to be more specific, so I decided to give you the real details of the nature of the roots. So one possibility is your d is less than 0, meaning it's a negative number. If that's the case, you're going to have two imaginary roots. And then the next possibility is this: the d, or your discriminant, is exactly equal to 0. Then you're going to have two identical rational roots. And the third one, d is greater than 0, and it's not a perfect square number. Let's say 5. Square root of 5 is decimal, so it's not a perfect square number. You are going to have two distinct irrational roots. And then finally, if d is greater than 0 and it's a positive perfect square number, say 16, square root of 16 is 4, or 36, square root of 36 is 6, you are going to have two distinct rational roots. Now, I mentioned earlier, some teachers, some books, they only divide the nature of the roots into two, so they actually group all of these three, and now you have imaginary only or real roots. But I want to be really specific, so I'm giving you these 4 possibilities. And also later on, I will show you, aside from explaining the nature of the roots, I will show you the graphical representation of the given quadratic equation for you to be able to understand. So if the roots are imaginary, what's the how's the graph look like? If the roots of a quadratic equation has two distinct rational roots, what's the image of the graph? So I will give you those kind of stuff later on. Okay, so let's answer the first example here. These are the problems that I'm going to discuss to you. X squared plus 6x minus equals -9. So what is the discriminant, and what's the nature of the roots? Here we need to add 9 on both sides, because if you remember on the first slide, you need to make sure that your quadratic equation is in standard form. So this is x squared plus 6x plus 9 equals 0. So our formula for that is b squared minus 4ac. A is 1, b is 6, c is 9. So this is 6 squared minus 4 times 1 times 9, right? 6 squared is 36. 4 times 1 is 4 times 9 is 36. So our discriminant is equal to 0. So what's the nature of the roots? If we go back to the table, let's go back to the table. So here, d is equal to 0. We'll be having two identical rational roots. Okay, so we will not solve this, meaning we will not find the roots of this one using factoring or quadratic formula. But by just looking at the graphical representation of this one, we'll identify the roots. So this is the graphical representation. It says there are two identical rational roots, and those roots are -3 and -3. Okay, now why is it 2? Why not 1 only? There's only 1 point of intersection. because we are talking about quadratic equations here. So quadratic equation has two roots. If you only have -3 as your root, then it's not a quadratic equation. It's linear. Okay? U-shaped graph, we learned that it's parabola, and we call this -3 multiplicity of 2, something like that. Okay? All right, let's go to the next example. We have here -5x squared plus 2, and you might be thinking, oh, this is not in standard form. Well, actually, this is in standard form, but there's no b here. I don't know if you noticed that there's no b. We only have two terms. So what we have here are a and c. Okay, since there's no b, that means b is equal to 0. So c is equal to +2. Okay, so this just to give you a reminder, not all quadratic equations have a, b, and c. But this is one thing you need to remember. It has always an a. Sometimes there's no b, sometimes there's no c, sometimes there's no b and c, but there will always be a. Okay? Alrighty, so let's solve the discriminant now. B squared minus 4ac, b is 0, a is -5, c is +2. So 0, -4 times -5 is +20. +20 plus times 2 is +40. So the value of the discriminant is 40, and if it's positive, it's divided into 2. This is the last two descriptions there from the table I showed you earlier. So the third one is this one. It's positive, but it's not a perfect square number. Square root of 40 is decimal. You are going to have two irrational roots, two distinct irrational roots. So let's see the graphical representation of this one. Okay, so there you go. The roots are here, all right? And we all know it's irrational because it's going to be decimal, right? But how will we know if it's irrational? Because if you try to find the square root of 40, it will give you an approximate equivalent, decimal equivalent of the square root of 40. So that's why I know that it's going to be irrational. Okay, and by just looking at the graph, we can't clearly see here the exact value of those roots. What we know is that there are two roots and they are irrational. Okay, we know that they are irrational because the discriminant is equal to 40. It's positive and it's not a perfect square number. Let's go to the third example. Okay, so this is not in standard form. We just need to switch 2 and -2 and 5x. So it's 3x squared minus 5x minus 2 equals 0. A is 3, b is -5, and c is -2. Okay, here's the formula. B is -5 minus 4 times 3 and -2. And there's the dog. Alright, -5 squared, that's 25. -4 times 3 is -12 times -2 is positive 24. We add these two, the answer is 49. That's the nature of the roots. That's the value of the discriminant, and we all know it's positive, and the square root of 49 is 7. So which means we will be having here, or the nature of the roots will be two distinct rational roots. Let's see the graphical representation of this function. Okay, this is +2. Now you might be thinking, that's going to be decimal. You are actually correct, but it's a rational number. It's not like 1 point and then the decimal is indeterminate. I think this is -1/3 if I'm not mistaken. So -1/3 is rational, 2 is rational. There you go, you have two distinct rational roots. Okay, let's go to the fourth and last example. Okay, this is perfect. We have a quadratic equation in standard form. A is 4, b is -3, and c is 5. Alrighty. B squared minus 4ac is the formula. This is negative 3 squared minus 4 times a, which is 4. C is 5. Negative 3 squared is equal to 9 minus 4 times 5. I want to multiply these two first. That's 20 times 4 is negative 80. So 9 minus 80 is equal to negative 71. So negative 71, which means it's a negative number, it's less than 0. And in this case, this quadratic equation has two imaginary roots. Let's look at the graphical representation. There you go. You will not see an intersection of the graph and the x-axis, right? Intersection is non-existent. So if you see this kind of graph, you're going to have two imaginary roots of your quadratic equation. And if you look at the discriminants, negative 71, you use quadratic formula, the square root of negative 71, it's going to be imaginary. All right, so that's the discriminant and how it relates to the nature of the roots of quadratic equation. I hope you learned something. Please do subscribe to my YouTube channel, like this video. Thank you, and have a nice day. Bye-bye.